Hi, welcome to the domain 11 of CCSK. This domain is focused on data security and encryption in the cloud. There are 6 questions can be expected from this domain in the exam. Especially this video is going to help you for CCSP exam as well because this covers a lot of technical stuff in terms of the data security and encryption, including the key management. This video will help you to prepare for the exam in lesser effort and time. Watch till the end to avoid any misconception. This video may be a little longer but very important topic. If you're watching my videos for the first time, please subscribe to the channel for the regular videos updates. Data security is a key enforcement tool for the information and data governance. Its use should be risk-based since it is not appropriate to secure everything equally. Because if you don't know what data is more critical and its breach may lead to the high risk, it is very important to know that what kind of data it is and what is the criticality of this data and what could be the risk, because every data may have the different risk, and based on those risks we should identify the data. They should be encrypted, they should not be encrypted. Evaluate the responsibility in the different deployments like IaaS, PaaS, SaaS. Try to encrypt everything in SaaS, especially because of the provider's trust. But encrypting everything is not a cure and may lead to false sense of security. So very important to arrive at a conclusion on the criticality of the data and evaluate the risk. That is the crux. Data security controls. While deciding the data security controls, there are areas we need to keep in the consideration. For example, controlling what data goes into the cloud and where, protect and managing the data in the cloud. The key controls and processes are like access control, encryption, architecture, monitoring and alerting of the the usage, configuration and lifecycle states. Additional controls, including those related to the specific product, service, platform of your cloud provider, maybe data loss prevention and enterprise risk management. Enforcing information lifecycle management security. Here, like managing the data locations and where it is going to reside, ensuring the compliance, including audit artifacts like logs, configurations, and backup and business continuity. Especially the backup and BCDR is a critical part of the information lifecycle. There are different storage types in the cloud. One is the object storage, volume storage, database, and CDN. The cloud storage virtualization technologies looks like something different than what is underneath. In terms of the object storage, it is similar to a file system. Objects are typically files which are then stored using a cloud platform, a specific mechanism. Most of the times these are accessed through the APIs, not a standard file sharing protocol. Although cloud provider may also offer front-end interface to support these protocols. Some examples for the object storage are like Amazon S3, Microsoft Azure, block binary large objects, and the Google Cloud Storage Services. Volume storage, this is essentially a virtual hard drive for instance or the VMs. A volume can be attached only to a single server instance at a time. So when we run a virtual machine, it stores or it creates a virtual hard drive on the machine. If You could have observed during the VM creation on your local machine, on your local laptop or desktop. You would observe that there is a VM SDK, um, or maybe different extension. That is the virtual hard drive for each VM, and similarly in the cloud, this volume storage, this is nothing but a virtual hard drive. Database, cloud platform and providers may support a variety of different kind of database, including the existing commercial and open source options, as well as their own proprietary systems. Proprietary database typically use their own APIs. Commercial and open source database are hosted by the provider and typically use existing standards for the connections. These can be relational or non-relational. The later includes the NoSQL and other key value storage systems, or like file system based databases. Like on Hadoop we have HDFS, Hadoop file system, so that is also considered in the database. Application platform, uh, the CDN, which is a content-driven network. So this is also known as the application or the platform storage, where files is stored in the SAS, caching, and other novel options. Um, like CDN is like these days we have the videos, a lot of videos, just like YouTube. You have Amazon, you have Netflix or Hotstar. These things are like CDN, content-driven network, and also known as the application or platform storage type. Especially when we are talking about the data storage, it is worth talking about the data dispersion. This is very important. Data dispersion. So what it is equivalent to RAID. RAID uh, is a you know the redundancy mechanism in the um, in the physical servers. For example, if you are using a server in your lab, and for the redundancy purpose, you can configure different kind of RAIDs, like RAID 0, RAID 1, RAID 5, RAID 10, things like that. So every it depends on your need and the requirements of your business or your project, um, and based on that you can choose the different RAIDs. But here the data dispersion is equivalent to RAID protection, but in the cloud the data dispersion is differently implemented. Any storage block is replicated in the multiple physical locations across your cloud. In private clouds, you configure this yourself, but in public cloud, it is likely an opaque feature. Dispersion is a great for resiliency and valuable for the security. Any given file might be broken up and stored on multiple hard drives. So losing one drive might not matter much, but you can rarely figure out exactly what data is stored on which drive. To further deep dive into the object or volume storage, um, physical storage is like SSD storage, where you have the physical devices kept in the rack and servers. Usually, the customer do not have access to these because these are under control of the cloud provider. Physical storage is generally pooled by the virtual storage controller, like a SAN, storage area network. So everything underneath in the form of physical storage, it is controlled by the virtual storage controller, and all the resources are pooled here. So when we talk about the object storage controller, it is also called as the storage manager, which is connect to the assigned physical or the virtual storage and manage the orchestration and the connectivity. Above this level, they communicate using APIs like RESTful APIs. The benefit of using the RESTful APIs is that they runs over the HTTPS protocol and makes end-to-end secure connection. This also creates the virtual container, also known as buckets, which are assigned to the cloud user. Container is a pool of storage in which you can place objects, files. Every container is stored each bit in the multiple location, and this is called as the data dispersion in terms of this object or volume storage, the data dispersion which we just talked about in the previous slide. The volume storage, it is similar to the object storage. Here the storage and manage orchestration and connectivity. Above this level, they communicate using APIs, just like the object storage controllers. Um, the volume controller creates the volume on request and assign them to the specific cloud instance. To use traditional virtualization language, it creates a virtual hard drive and connect it to a virtual machine. A volume is essentially a persistent virtual hard drive here. It cannot be of any size supported by the cloud platform, and yeah, it can be of any size actually, because it depends on the user, or it depends on the provider, what is the demand and what is the request. The volume assigned to a virtual machine exists until it is destroyed. Um, the physical servers here, they runs hypervisor and cloud connectivity software to tie them into the compute resource pool. This is where the instances, the virtual machines runs. And these servers typically have local hard drives, um, which can be assigned um, to the volume controller to expand the storage pool, or used locally for the non-persistent storage. We call this ephemeral storage, and it's great for the swap file and the other high performance operations that don't require the resiliency of full storage volume. If your cloud uses this model, the cloud management software places swap on these local drives. When you move or shut down your instance, this data is always lost, although it might be recoverable until overwritten. Data migration to the cloud. So before we migrate the data to the cloud, first evaluate what all compliances you need to meet, whether it requires private cloud or public cloud will work here. Define the policies for the data security. To detect actual migration, monitor cloud usage and any data transfer. You can do this with the help of these tools. um, CASB, Cloud Access and Security Broker. This is also known as the Security Gateway. This discovers internal use of the cloud services using various mechanisms such as network monitoring, integrating with an existing network gateway, or monitoring tools, or even by monitoring the DNS queries. After discovering which service your users are connecting to, most of these products, when offering the monitoring of the activities on the approved services through API connections, or maybe inline interception, man in the middle monitoring. Many supports the DLP, data loss prevention, and the other security alerting, and even offer control to better manage use of the sensitive data in the cloud services in SPI, SaaS, PaaS, and IS. Um, URL filtering, while it is not as robust as CASP, URL is also known as the web gateway, which may help you understand which cloud services your users are using or trying to use. Data loss prevention. If you monitor the web traffic and look inside the SSL connection, data loss prevention tool may help detect data migration to the cloud services. However, some cloud SDKs and APIs may encrypt the portion of data and traffic that DLP tool cannot identify, and thus they won't be able to understand the payload. So that is the limitation of the DLP. That if the data is encrypted, it is difficult to monitor that, to identify that what kind of data it is. During the transfer security, so when you migrate the data to the cloud and you're transferring the data, so it is important to ensure that you're protecting your data as it moves to the cloud. Use APIs that supports HTTPS, or if you are doing it manually, choose SFTP, secure FTP, and the proxy-based encryption. So these are the few things which should be taken care during the data migration. Securing cloud in the securing data in the cloud. So there are three aspects here. Cloud data access control. So who can access and when can access. This is very important. Storage at rest, encrypt and tokenize the data at rest. Key management, so including the customer managed keys. So key management is the important topic because any encryption, it is going to require the key management, because key management is the backbone of the encryption engine. Because to protect the keys is more important to protect the data. Cloud data access control, management plane. There are these are your controls for managing access of the users that directly access the control cloud platforms management plane. For example, logging into the web console of IS service will allow that user to access data in the object storage. Fortunately, most cloud platforms and providers start with the default deny access control policy. Very important to consider that in the cloud. Default deny. Public and internal sharing control. If the data is shared externally to the public or partners that don't have direct access to the cloud platform, there will be a second layer of control for this kind of access. Application level control. As you build your own application on the cloud platform, you will design and implement your own control to manage the access. Storage, encryption, and tokenization. So there are different requirements at the different service model, like for IaaS, PaaS, and SaaS. So different needs and different type of controls are suggested and recommended in the cloud. When we talk about the IaaS encryption, it is basically the encryption and tokenization. These are the two different technologies. Encryption protects the data by applying a mathematical algorithm that scrambles the data, which can then be recovered by using it through an unscrambling, also known as the decryption process, which is a corresponding with the corresponding key. The result is the ciphertext. And similarly, when you have to perform, you have to extract the data, you perform the reverse. There are three components of the encryption system. One is the data which you want to encrypt, and another is the encryption engine which is actually processing your data and trying to encrypt it. And the third one is the key. So key, data, and encryption engine, these are the three important component of any encryption system. Tokenization, on the other hand, takes the data and replaces it with the random data. It then stores the original as well as the randomized version in the secure database for later recoveries. For example, if you have the credit card number XYZ maybe, but then token can be ABC. So when you are using that credit card number, you don't need to share the actual credit card number here to there. You can just use that token, sharing it with the different applications or with the different systems whenever you're talking based on that token. When designing the encryption strategy, start with the threat modeling, especially how keys can be exposed, where should be the encryption engine. On the client side or on the cloud side with the provider. So that all depends on the threat modeling to decide on the encryption strategy. Volume storage encryption. There are two terminologies, two types in the storage volume storage encryption. One is the instance managed encryption, externally managed encryption. So instance managed encryption is when the encryption engine runs within the instance and the key is also stored in the volume. But that key can be protected by a passphrase or a key pair. For example, when we talk about the volume and especially the instance managed encryption key, you have a Linux VM and you have to protect that Linux VM's hard drive or the partitions or the volume. Then what you can do is you can use the LUK. LUK is the Linux Unified Key Setup. So this LUKS is a standard mechanism to protect the volume. The externally managed encryption, where the encryption engine runs within the instance, but the keys are managed externally and issued to the instance on request. On the object and file storage encryption, different requirements and there are different ways to protect, or different ways to encrypt. So depend on the threat model and the risk that we identify. There are three different methods here: client-side encryption, server-side encryption, and proxy encryption. When we talk about the client-side encryption, the objects storage is used as the backend for an application, including the mobile application, etc. Encrypt the data using an encryption engine embedded into the application or the client. So that client remains responsible for encrypting the data. Server-side encryption, where the data is encrypted on the server, on the cloud itself, by the cloud service provider after being transferred in the cloud. The cloud provider has access to the key and runs the encryption engine. So the cloud provider runs the encryption engine. He is holding your encryption keys. He is holding your data. So you can perform the threat analysis and then decide that what could be the issues with this approach. In proxy encryption, in this model, you connect the volume to the special instance and the application software, and then connect to your instance to the encryption instance
The proxy handles all the crypto operations and may keep the keys either on board or externally. PaaS encryption, in the platform as a service, there are different methods like application layer encryption, where the data is encrypted in the PaaS application, or the data or the client accessing the platform when you are running the application in a platform as a service environment. Any required encryption service are generally implemented within the application itself or on the client accessing the platform. Database encryption. The data is encrypted in the database using the encryption that's built in and is supported by a database platform like TDE, the transparent database encryption. It can also work at the row level, at the column level, or at the table level. So, however you want to encrypt your database. Others are there are provider managed layers in the encryption in the application, such as the messaging queue. There are also IAS options where that is used for underlying storage. SaaS encryption, SaaS providers may use any of the options previously discussed. It is recommended to use per customer key when possible in order to better enforce the multi-tenancy isolation. Provider managed keys, data is encrypted in the SaaS application and generally managed by the provider. While in the proxy encryption, the data passes through the encryption process, encryption proxy before being sent to the SaaS application. So this is like a gateway. Whatever data is leaving our network, it has to be encrypted before leaving the network or before going into the SaaS application. The key management, including the customer managed keys, this is very important topic to understand how the keys are being managed, what all methods are there. The main consideration for the key management are performance, accessibility, latency, and security. Can you get the right key to the right place at the right time while also meeting your security and compliance requirements? So to answer this question, you need to go through these options, and these options will help you to meet your organization requirement or depending on your policy, depending on your data criticality, what could be the risk. HSM or the appliance use a traditional hardware security module or appliance-based key manager, which will typically need to be on-premise and deliver the keys to the cloud over a dedicated connection. The keys remains uh, on-premise, not in the cloud, and these keys are in the physical HSM on-prem. Virtual appliance or the software deploy a virtual appliance or software-based key manager in the cloud. Um, this is also equivalent to the HSM, which is a hardware appliance, and this virtual appliance is also kind of equally certified appliance or the key manager, which is running inside the cloud. Cloud provider service. This is a key management service offered by the cloud provider. Before selecting this option, make sure you understand the security model and SLA to understand if your key could be exposed. So here, if you are storing your data in the cloud and you are storing, if you are relying on your cloud provider to store the keys, then your cloud provider is going to have your data and your keys as well. So indirectly, they may have access to your data. Hybrid, you can also use a combination such as using HSM as a root of trust for the keys, but then delivering the application specific keys to the virtual appliance that's located in the cloud and only managed keys for its particular context. The customer managed keys, the keys allows a cloud customer to manage their own encryption keys while the um, the provider manages the encryption engine. So in some cases, let's say, for example, using your own key to encrypt the SaaS data within the SaaS platform. Many providers encrypt the data by default using the key completely in their control. Some providers may need customers to manage the keys within the provider control, within the provider cloud. So indirectly, provider will have access to your keys, but doesn't mean it is insecure. But at the same time, we need to understand that your provider is going to have your keys as well as your data. Since the key management and data storage systems can be separated, it would require collusion on part of the multiple employees at the provider to potentially compromise the data. However, keys and data could still be exposed by the government request depending on the local laws, and you may be able to store the keys externally from the provider and only pass them over on the per request basis. Let's take a look on some questions. Which of the following deployment model allows for the customer to have complete control over the encryption key management when implemented in a cloud in a provider's cloud environment? So one important aspect we need to understand here is if you want to have the full control or the complete control over the encryption key management, and you want to keep the data and the keys separate or isolated, then it is and you want to rely on the cloud. So in this question, the cloud environment is the keyword and the complete control. So HSM, appliance-based key management, it requires the on-prem access because hardware-based HSM, the appliances are going to be on-prem. Virtual appliance, software key-based software key management, these are going to rely on the cloud and will be in the control of customer. Provider managed keys, this is of course to be under provider control. Customer managed keys, this is again you have to manage the keys maybe outside um, or maybe in the cloud. But here in this, the B and D are the right answer, but B remains the best answer here because indirectly this is the virtual appliance, this is in the control of the customer. Or if you want to outsource this, this will be separate from your provider. A redundant durable data storage mechanism used in the cloud. So here when we say redundant, so redundancy is the key. So in the cloud, if and data storage here, this is a hint in this question. So we are talking here the redundancy in the data storage. So what is the redundancy in the data storage? We talked about the data dispersion, which is the important terminology here. The right answer is the data dispersion. Data loss prevention. The DLP solution might not work properly if the data is. So what we talked about, what is required by DLP, because DLP opens the packet and checks that what kind of data being traveled, and then accordingly it can label, it can encrypt that. But if the packet is already encrypted, it cannot identify that what kind of data it is. So C is the right answer here. If your organization must accept untrusted data into its cloud environment, such as public input, it is important to what? So here you are accepting the untrusted data. So any untrusted data has to be first isolated and scanned before you add that to the pool. You should not accept the data as is, and first it has to be scanned. So A is the right answer. Thanks for watching. With this, we conclude the CCSK Domain 11 Data Security and Encryption. Thanks for watching the full video. I hope you like the video. Please subscribe, like, comment, and share in your network so that others can take benefit for their exam preparation. Thank you.